along with me. So if all the members of one set are also the members of a second set, then the first set is said to be a subset of the second set. So if everything in one set is inside the other set, it is a subset of that set. So it'll make more sense when we do an example. These are obviously equal sets, right? They have the exact same elements inside of them, 1, 2, and 3, and 1, 2, and 3, which means that we call that an improper subset of A. So C is an improper subset of A, or A is an improper subset of C. You don't have to write this definition down either. It is in your book, and I'm pretty sure we don't do a lot of questions on it, but just so you have seen it, okay? You might want to write down these two definitions. A set that has no members, all right? There's no elements in the set. What we have is an empty set or a null set. Those mean the same thing, but I would like to see these symbols. So empty brackets with like nothing in them, or this like 0 with a slash through it, okay? So write those two down. By the way, the empty set is a subset of every set, all right? It's always a subset of another set because it has nothing in it. So, no. So, go ahead and write down these two sets. So, A is equal to, squiggly brackets, 0, 1, 2, 3, dot, 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 dot. So, write down set A. Then write down set B. So set A, you guys, is infinite. It goes forever, right? Set B is not infinite. We've got 0, 2, 4, and 6. That's the only numbers in set B. And then set C is also not infinite, also known as finite. So 1, 3, 5, and 7. So write those three sets down, and then we'll talk about what is a subset of. Okay. Tell which of the following assertions are true and which are false and why. So B, and this symbol here, you guys, you have to know what this means. So write this down. It means is a subset of. Okay? So this sideways, whatever this is, U, all right? Okay, so B, anytime you see this and you read it, you want to read it to yourself. B is a subset of C. So I want to know, is that true? Is B a subset of C? So in order to be a subset, all the elements from that set have to be in the other set. What do you guys think? No, C does not have those numbers in it, right? So this would be false. All right, so the next thing says B is a subset of A. So again, you have to know what this says. B is a subset of A. So B, does B fit into A? It does, you guys. This has dot, 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 right? We've got the 0 in this set, the 2 in the set. This keeps going, 4, 5, 6. We've got the 4, we've got the 6. So all the elements of B are inside of A. So this is true. Okay. All right, C is a subset of A. So set C we've got right here. Does set C fit inside of set A? Does A have all the elements of C? What do you guys think? Yes. 1, 3, 5, 7 are in set A. True. Okay. Now we need to talk about some other definitions. You definitely want to write these down. These are all real numbers, and these are different sets of real numbers that you want to memorize. Okay? Starting with the smallest set, natural numbers here. Natural numbers are also sometimes called counting numbers. You might want to write that down too. Counting numbers. Makes sense. When you're 2 years old, you start learning 1, 2, 3, right? You don't start at like -6, -5. That would be cool, but you don't. All right, so the counting numbers are the natural numbers, 1, 2, 3, etc., forever, upward. No decimals, no fractions, right? Just whole numbers, 1 and up. Okay, Then we have what's called whole numbers. What's the only difference between the natural numbers and the whole numbers, Monica? It has a 0. That's it. So the whole numbers are the exact same thing, but with 0. 0, 1, 2, 3, 4, 5, 6, 7. Okay? And then we have the integers. And by the way, you do want to use these N's, W's, and this Z with the double bar. A lot of times these have like double bars for when we're talking about a set of numbers, okay, on the letter. So Z is the integers. So the integers is every single positive and negative number and 0, but no fractions, no decimals, okay, but all the positives and all the negatives. These are all subsets of the real numbers. So who can tell me one of these that's a subset of another one of these? Raise your hand if you tell me that something is a subset of something. Leah. Very good. N is a subset of W. All of those N numbers fit inside of W. Give me another one, Corey. Yep. W is a subset of Z. All the whole numbers fit inside of the Z numbers. Okay? Yep. Andrew. N is also a subset of Z. Exactly. Okay? Makes sense? Okay, good. Real numbers. So, this is important as well. We have real numbers, and they break into two sets of numbers. So, you want to write these down. Real numbers break into either rational or irrational. So, everything you guys know of so far in your life of math is real. Eventually, you'll get to imaginary. It's super fun. So, inside of real numbers are rational numbers and irrational numbers. And we just talked about 3 subsets of rational numbers. So rational numbers also include integers, whole numbers, and natural numbers. So those sets that we just talked about are always included in rational numbers. But guess what else rational numbers includes? Isaac? Fractions and decimals. All right? So rational numbers also have the fractions and the decimals and the integers and the whole numbers and the natural numbers. Okay? Those are all rational numbers. And then we have the weird numbers. Those are irrational. So irrational numbers, the ones that you guys are familiar with so far are numbers like pi. So irrational, you might want to make a note of this, cannot be made a fraction. Okay? Cannot be a fraction. So pi, can pi ever be a fraction? No, not an exact one, okay? This lovely forever ever decimal that keeps going right here cannot be made a fraction. But if I gave you a number like 0.3333 repeating, is that rational or irrational, you guys? Why is this rational? It's 1/3, so it's the same as 1/3, so it's rational, okay, because it's a fraction. Irrational, square root of 3, square root of 2, square root of 7, square root of 10, square root of 5. But what about the square root of 9, you guys? Is that rational or irrational? Rational. It is rational. Why? Because it's 3, right? So make sure you don't think that every square root is irrational. If it's a nice square root, it's rational. If it's not a nice square root, it's irrational. All right? So what subsets of real numbers do the following numbers fall into? So 11/6, and you have to know what this lovely E symbol is. It's like a curved E. This means, and you should write this down, is an element of. So 11/6 is an element of. We do the squiggly brackets, and we're going to talk about what sets 11/6 falls into. Every single number that you guys do right now is real. So you're always going to put real every time, because every number that we talk about is real. The next step is to say, is it rational or irrational? Okay, it's one or the other. It cannot be both. So what do you guys think, rational or irrational? Rational. Yeah, this is rational. It is a fraction. And then you ask yourself, is this an integer? No, integers are not fractions, right? Integers are all the negatives and positives, but not fractions. So we don't get to go any further. we're done. Oh, I messed that. Okay. All right, write down the next one. 0.62 is an element of, so Nate, what do I always put for the first one? A real number. And then we ask ourselves, is it rational or irrational? Dylan, what do you think? Rational or irrational? Yes. If it's a decimal that ends, can we make that a fraction? Yeah, that's 62 over 100, right? Which reduces, but yeah, okay? So this is rational. All right, here we go. Real, rational, and then you guys, is 0.62 an integer? No, so this is the same answer as the last one. All right, boom, real, rational. All right, 4, write this down every time. Everyone writes down. 4 is an element of. So Nick, what do I always put first? Real. Okay. And then it's either rational or irrational. Lucas, which one is it? It is rational. Most of them are. Okay. And then we have to say, is it an integer? Alex, what do you think? Integer? Yes. Integers are all the negatives and all the positives, right? And then the next set down below integers is whole numbers. Riley, is it a whole number? Yeah, whole numbers are 0 and up. Okay, and then Ella, is it a counting number? Yes, or natural. And that's as far as it goes. So guess what? Every single thing that is 1 and up is going to be all 5 of those, right? 1 and up every time is natural, whole, integer, rational, real. Okay? So any number 1 and up, you should have 5 things. And as long as it's not a decimal or a fraction, right? Okay. 2 root 2 is an element of. Caleb, what's the first thing we always put? Real. And Nico, is it rational or irrational? Yes. This one is irrational because it has a weird square root that's not nice. Okay? If it was a square root of 9, that would be different. Okay. And now we have negative 4. So, let's see. I'm going to make someone tell me all of them. How about Micaiah? What is this one going to be? Ooh, what do you guys think? I'm with you on some of them. Sophia, what do you think? Yes. Do we go into the whole numbers? Whole numbers are not negatives. Neither are counting numbers, right? So this one only has 3 things: real, rational, integer. So any negative nice number is always these 3 things. Okay? All right, let's try it on the whiteboards and see how we do.